Hi guys, welcome back to Nerd Talk. I am really excited to have you here, so sit back, relax, and get ready for our 12th journey together. In this video series, we are going to explore one of the greatest stories ever told, the story of the universe itself. From the birth of stars inside glowing nebula to their dramatic deaths as supernovae, neutron stars, and black holes, we will uncover how everything in the cosmos evolves. We will journey through galaxies, understand their structure, their motion, and the mysterious dark matter that holds them together. Along the way, we will witness the most powerful events in existence, cosmic explosions, collisions, and the creation of elements that make up planets and even life itself. By the end of this journey, you will realize that the universe is not just something out there, it is something you are a part of.
What is a star? Look up at the night sky, and what you see may seem calm and silent. But each tiny point of light is actually a massive, burning sphere of energy. A star is a gigantic ball of hot plasma, powered by nuclear fusion at its core. Inside it, atoms collide and merge, releasing incredible energy every second. This energy travels outward, lighting up the darkness of space. Our sun, the source of life on Earth, is just one ordinary star among billions.
Nebula. Long before a star is born, there exists a vast cloud drifting silently in space. These clouds, known as nebulae, are made of gas and cosmic dust. They stretch across light years, glowing softly in shades of pink, blue, and purple. Inside them, gravity begins its slow and patient work. These are the wombs of stars, quiet yet full of potential.
Gravity collapse. Within this peaceful nebula, a subtle force begins to dominate: gravity. Tiny regions start pulling matter inward, growing denser over time. As more gas gathers, the pressure and temperature begin to rise. The collapse becomes faster, more intense, unstoppable. A star's story begins not with light, but with a silent fall inward. Protostar. At the center of this collapsing cloud, a glowing core begins to form. This is the protostar, the earliest stage of a star's life. It is not yet shining like a true star, but it is growing hotter every moment. Energy builds within, trapped by the surrounding gas and dust. It is a star in the making, waiting for the moment to ignite. Fusion ignition. As the core temperature rises to millions of degrees, a transformation occurs. Hydrogen atoms begin to fuse together, forming helium. This process releases an enormous burst of energy. The outward pressure finally balances gravity's inward pull. In this instant, a star is truly born, shining for the first time.
Now the star enters the longest phase of its life, the main sequence. Here, fusion continues steadily, producing light and heat. A delicate balance is maintained between gravity and pressure. This stability allows the star to shine for billions of years. It is a long, calm chapter in an otherwise dramatic life.
During this period, the star appears unchanging to distant observers. Its brightness remains constant, its structure steady. But deep inside, hydrogen is slowly being consumed. Time passes quietly, almost unnoticed. Yet this calm phase is only temporary.
Eventually, the core runs low on hydrogen fuel. Gravity begins to compress the core once more. In response, the outer layers expand dramatically. The star swells into a red giant, glowing with a cooler, reddish hue. It becomes enormous, a shadow of its former stability. For massive stars, the ending is not gentle. It is explosive. The core collapses in a fraction of a second. Then, a shockwave blasts outward, tearing the star apart. This is a supernova, one of the most powerful events in existence. In moments, it releases more energy than the sun will in its lifetime. Not all stars end in violence. Smaller stars shed their outer layers slowly into space. What remains is a small, dense core, a white dwarf. It no longer produces energy, but still glows with leftover heat. Over billions of years, it will slowly fade into darkness.
A neutron star. After a supernova, the core may collapse into something extraordinary. Matter is crushed so tightly that atoms are destroyed. Protons and electrons merge to form neutrons. The result is a neutron star, incredibly dense and compact. A single spoonful would weigh more than a mountain.
Pulsar. Some neutron stars spin at incredible speeds. They emit beams of radiation from their magnetic poles. As they rotate, these beams sweep across space. From Earth, they appear as rhythmic pulses of light. Like cosmic lighthouses, they flash endlessly in the dark.
Black hole. If the collapsing core is massive enough, nothing can stop it. Gravity overwhelms all forces, compressing matter endlessly. The star collapses into a point of infinite density. Around it forms a region where nothing can escape. This is the birth of a black hole, the ultimate cosmic mystery.
Not all stars share the same destiny. Small stars end quietly as white dwarfs. More massive ones become neutron stars. The most massive collapse into black holes. In the universe, size determines fate.
From birth in nebulae to death in explosions, stars live incredible lives. They create elements and scatter them across space. These elements form new stars, planets, and even life. The universe is a cycle of creation and destruction. And in that cycle, we find our own origins.
What is a galaxy? Zoom out far beyond a single star, and an entirely new structure appears. A galaxy is a massive collection of billions or even trillions of stars. Along with stars, it contains gas, dust, and an unseen component called dark matter. All of this is bound together by gravity, forming a vast cosmic system. Galaxies are the true building blocks of the universe's large-scale structure.
Milky Way structure. Our home in the universe lies within the Milky Way. This galaxy has a bright central bulge surrounded by sweeping spiral arms. Our solar system is located in one of these outer arms, far from the center. At its core lies a supermassive black hole, influencing everything around it. Even at the speed of light, crossing it would take over 100,000 years.
Spiral galaxies. Spiral galaxies are among the most visually striking structures in the universe. They have flat, rotating disks with elegant arms spiraling outward. These arms are filled with gas, dust, and newly forming stars. The rotation is slow, taking hundreds of millions of years for one turn. They are dynamic, constantly forming and evolving systems.
Elliptical galaxies. Not all galaxies have the graceful arms of spirals. Elliptical galaxies appear smooth and rounded, almost like glowing spheres. They contain mostly older stars and very little gas. Because of this, new star formation is rare within them. They often form after massive galaxy mergers. Irregular galaxies. Some galaxies defy structure completely. Irregular galaxies have no defined shape or symmetry. They often look chaotic, with stars scattered unevenly. This irregularity is usually caused by gravitational interactions. Despite their chaos, they are rich in gas and star formation.
Galaxy clusters. Galaxies rarely exist alone in the vastness of space. They gather together to form galaxy clusters. These clusters can contain hundreds or thousands of galaxies. They are bound together by immense gravitational forces. On the largest scale, they form a cosmic web across the universe. Gravity binding galaxies. Gravity is the invisible force that holds galaxies together. It keeps stars orbiting their galactic centers, it binds clusters, and shapes the structure of the universe. Without gravity, galaxies would simply disperse into space. It is the architect of cosmic order. Galaxies are not static. They rotate slowly over time. Stars orbit the center, much like planets orbit a star. However, outer stars move faster than expected. This challenges our understanding of visible matter. It hints at something hidden influencing their motion. Dark matter. To explain galaxy rotation, scientists proposed dark matter. It does not emit light and cannot be seen directly, yet it makes up most of a galaxy's mass. Its gravitational pull holds galaxies together. Even today, it remains one of the biggest mysteries in physics. Galaxy evolution. Galaxies are constantly changing over billions of years. They collide, merge, and reshape themselves. These interactions trigger bursts of new star formation. Over time, galaxies grow larger and more complex. The universe is not static. It is always evolving. Supernova types. Not all supernovae are created in the same way. Some occur when massive stars collapse under their own gravity. Others happen in binary systems, where one star steals matter from another. When a critical limit is reached, a thermonuclear explosion occurs. Both types release extraordinary amounts of energy. Neutron-star collision. In rare cases, two neutron stars spiral toward each other. As they collide, they release immense energy and gravitational waves. The collision creates heavy elements like gold and platinum. These elements spread across space, becoming part of future planets. Such events are among the most powerful in the universe. Gamma-ray bursts. Gamma-ray bursts are the brightest explosions ever observed. They release intense radiation in just a few seconds. These bursts can be detected across billions of light years. They are often linked to supernovae or neutron star mergers. For a brief moment, they outshine entire galaxies. Black hole formation. When a massive star collapses completely, it forms a black hole. The core shrinks into an infinitely dense point. Around it forms an event horizon, trapping everything inside. Matter falling in forms a glowing accretion disk. Black holes continue to grow as they consume material. Star nurseries. Even as stars die, new ones are being born. Nebulae continue to form fresh generations of stars. Radiation from nearby stars makes these clouds glow beautifully. They are rich in gas and dust, perfect for star formation. The universe is constantly renewing itself. A star's fate depends entirely on its mass. Small stars become white dwarfs. Larger ones collapse into neutron stars. The most massive form black holes. Mass is the deciding factor in stellar evolution. Supernovae release unimaginable amounts of energy. Shockwaves travel through space at incredible speeds. These waves compress nearby gas clouds. This can trigger the formation of new stars. Destruction leads directly to creation. Cosmic recycling. The universe recycles everything. Material from dead stars spreads across space. This material forms new stars, planets, and systems. Elements essential for life are reused again and again. We are part of this endless cosmic cycle. Heavy element formation. Heavy elements are forged in extreme cosmic conditions. Supernovae create many of these elements. Neutron star collisions produce even heavier ones. These elements become part of planets and life forms. Even the gold we value on Earth comes from such events. Iron core collapse. In massive stars, Fusion eventually produces iron in the core. Iron cannot release energy through fusion. This causes the core to collapse suddenly. The collapse triggers a massive supernova explosion. It marks the final stage of massive stellar evolution. From tiny particles to massive galaxies, everything is connected. Stars create elements that form planets and life. Galaxies organize these stars into vast systems. Cosmic events reshape the universe continuously. It is a grand, interconnected system.
The universe is not silent or still. Stars are being born and dying every moment. Galaxies move, collide, and evolve over time. Energy flows endlessly through space. It is a dynamic, ever-changing system. Every atom in your body was once inside a star. You are made of material forged in cosmic explosions. The universe is not separate from you. You are part of it. By understanding the cosmos, we understand ourselves. And the story of the universe continues beyond imagination.
Thanks a lot for watching. If you're liking the videos, please do like, share, and subscribe.